There could be a silent danger in your home. It's radon, a naturally occurring radioactive gas that you can't see, smell, or taste. Radon is the second leading cause of lung cancer and is responsible for about 21,000 lung cancer deaths each year in the US. Radon gas is formed underground from the breakdown of uranium in rock and soil. It can seep into your home through cracks in the foundation, basement, or crawl space. Radon can become trapped inside our homes and be present at dangerous levels. When you breathe air containing radon, tiny radioactive particles get trapped in your lungs. These particles break down and release small bursts of energy that can damage lung tissue. Over time, this can lead to lung cancer. There are no immediate symptoms from radon exposure, and it has no irritating effects or warning signs. The only way to know if your home has a radon problem is to test for it. Do-it-yourself test kits are simple to use and inexpensive. You can also work with a professional to test your home. If your test results show elevated levels, work with a professional to install a mitigation system to fix the radon problem. These systems collect radon gas from underneath the home and vent it to the outside, reducing radon levels indoors. Knowing your level of radon risk and fixing it if high levels are present may save a life. Test, fix, save a life. Learn.
Hi, so today our group will be presenting about radon issue and prevention. The introduction to the topic is radon is a naturally occurring radioactive gas produced by the decay of uranium in soil, rocks, and groundwater. It is colorless, odorless, and tasteless, making it impossible to detect without specialized equipment. Radon can enter buildings through cracks in floors, walls, foundation, and pipes. When trapped indoors, radon can accumulate to dangerous levels and pose serious health risks. The importance and significance to modern physics. Radon is closely related to the study of radioactivity and nuclear decay in modern physics. It helps scientists understand radioactive emissions and radiation exposure. Radon research contributes to environmental physics and health physics. Understanding radon is important for developing radiation safety measures and protecting public health. Some methodology of gathering information are review academic journals and physics textbooks, use information from government and health agency websites, and watch educational videos and online lectures. There are some challenges encountered like radon cannot be detected without testing equipment and public awareness about radon is still low. Some proposed solutions are increase public awareness through education and promote regular radon testing and improve building ventilation.
Now, I will explain the modern physics concept behind radon and its importance. Radon is a naturally occurring radioactive gas that is produced through the radioactive decay of radium-226. This process is an important concept in nuclear physics because it demonstrates how unstable atomic nuclei release radiation to become more stable. As shown in the equation, radium-226 decays into radon-222 while emitting an alpha particle, which is actually a helium nucleus. Although alpha particles cannot penetrate our skin, they become dangerous when radon gas is inhaled. Inside our lungs, these alpha particles can damage cells and DNA, increasing the risk of lung cancer after long-term exposure. Therefore, understanding radioactive decay not only helps us learn the principles of modern physics, but also allows scientists to develop radiation safety measures, improve environmental monitoring, and protect public health from the harmful effects of radon exposure.
Example related to radon. Radon accumulation in basement and underground buildings. Exposure in mines and poorly ventilated workplace. Use of radiation detector to measure radon levels. And health study linking radon exposure to lung cancer. Next is applicability in daily life. Radon affect daily life because people may unknowingly inhale it at work, home or school. Preventive measures such as proper ventilation and radon testing can protect human health. Modern homes now use radon-resistant construction method to reduce exposure. Lastly, recent advancements or studies related to radon, improved radon detection technology, smart home monitoring system for indoor air quality, research on the relationship between radon exposure and cancer risk, and government safety guidelines for acceptable indoor radon level. Many countries are also improving building regulation to reduce indoor radon accumulation.
Next, I will talk about the self-development for a career in modern physics, focusing on radon and radiation studies. First, let's look at the potential careers in this field. There are many exciting career opportunities, such as becoming a nuclear physicist, health physicist, radiation safety officer, environmental scientist, medical physicist, or nuclear engineer. These professionals play important roles in studying radiation, protecting public health, and developing technologies in medicine, energy, and environmental safety. Next are the skills needed for career excellence. A strong understanding of nuclear physics and radioactivity is essential. Besides that, laboratory research and skills are important for conducting experiments and analyzing results. Problem solving and data analysis skills help scientists make accurate decisions, while communication and presentation skills are necessary to explain research findings clearly. It is also important to know how to operate radiation detection instruments safely and effectively. Another important aspect is continuous self-development. Radiation technology is constantly advancing and safety standards continue to improve. Therefore, professionals must keep learning by attending workshops, reading scientific journals, participating in research projects, and staying updated with the latest international safety regulation. Continuous learning helps them remain competent and contribute to scientific progress. Finally, there are several challenges in this field. These include handling radioactive materials safely, understanding complex physics concepts, and dealing with limited awareness and research facilities in some countries. To overcome these challenges, professionals should receive proper training, gain practical laboratory experience, collaborate with experts, and always follow radiation safety procedures. In conclusion, self-development is essential for building a successful career in modern physics.
In conclusion, radon is an invisible radioactive gas that poses a serious health risk despite being naturally present in our environment because it has no color, smell, or taste. Many people are unaware that they may be exposed to dangerous levels of radon in their homes, school, or workplaces. Through this project, we have learned that radon is closely related to the concept of radioactivity and nuclear decay in modern physics. We also discovered that prolonged exposure to radon can significantly increase the risk of lung cancer, making early detection and prevention extremely important. Fortunately, there are effective ways to reduce radon exposure, such as conducting regular radon testing, improving indoor ventilation, sealing cracks in building foundations, and increasing public awareness through education campaigns. As technology continues to advance, better detection systems and safer building designs will help minimize radon-related risks. Overall, understanding radon not only strengthens our knowledge of modern physics, but also highlights how scientific knowledge can be applied to protect public health and create a safer living environment for future generations. Thank you.